page 438, 13 through 21 odd, and then 27 through 37 odd. We're going to be talking about ellipses today, and so you probably want to get out your blue sheet that has all the information on an ellipse. Like I said before, a circle is an ellipse where A and B are equal. An ellipse is a set of all the points P in a plane such that the sum of the distances from P to two fixed points called foci is constant. So on my picture here, and on your picture on your sheet of paper, I have a version of an ellipse. When we talk about an ellipse is either vertical or horizontal. This particular ellipse is horizontal because the major axis, which goes from here to here, is the longest axis, and it is horizontal. The axis from here to here is called the minor axis, and it, in this case, is vertical. So the major axis is the longest axis of symmetry. The minor axis is the shortest axis of symmetry. The center is considered H and K, and the fixed points on the ellipse are called foci. So this distance from here to here is the major axis. This distance from here to here is the minor axis. This is the center. The distance from here to here is A. The distance from here to here is A. The total distance from endpoint to endpoint is 2A. This distance is B, and this distance is C. So the total distance for the minor axis is 2B. Like I said, the focus is on the major axis. There are two of them. The distance from the focus to the center is considered C, and from the focus to the center is C. Distance from foci to foci, that distance is 2C. So on your sheet of paper, your blue sheet, I have given you the formulas for an ellipse that is horizontal and an ellipse that is vertical. I have also given you the information for the vertices, how to find those. We'll work those in a few minutes. And the equation for the focus is C squared is equal to A squared minus C squared. Once again, this distance is equal to A. That distance is equal to A. This distance is equal to B. That distance is equal to B. The whole distance from here to here, or the length, is equal to 2B. And the whole distance from here to here is equal to 2A. The focus is always on the major axis, and the distance from the focus to the center is C. Okay? And the total distance is 2C. The first example that I have says 16x squared plus 4y squared is equal to 144. The homework exercises 27 through 37 odd. You're given the equation, you're asked to write it in standard form, and then you're asked to graph it. There are specific things that I want you to find while you're doing this, and I have them listed. This equation is fairly simple. The first thing you want to do is rewrite this as 16x minus 0 squared plus 4 times y minus 0 squared is equal to 144. For be in standard form, it needs to be in the form of x minus h squared plus y minus k squared equal 1. And then we have to decide whether a squared, where a squared and b squared are. So I'm going to put this over here till we determine whether this is a horizontal or a vertical ellipse. The larger denominator determines the major axis. The larger denominator determines the major axis. So here we need to make our equation equal to what in order for it to be in standard form? So we're going to divide by 144. And when we do, we get x minus 0 squared over 9 plus y minus 0 squared over 36 is equal to 1. Here is when we wanted to determine whether the major axis is the x-axis or the y-axis, whether it's horizontal or vertical. The larger denominator determines the major axis. So which axis or what? Correct. It is y. So we know that it is a vertical ellipse because A is the larger number and it's under y. The center is 0, 0. Major axis is right to determine is the y-axis. Minor axis is the x-axis. A squared is equal to 36. So A is equal to plus or minus 6. B squared is equal to 9. So B is equal to plus or minus 3. The length of the major axis is 2A. So it is 6 times 6 or 12. The length of the minor axis is 2B. So it is 2 times 3 is 6. We'll come back to the vertices in a minute. Let's go ahead and graph what we have. So we'll plot the center at the origin at 0, 0. The reason you have found A as plus or minus 6 is because you're going over 6 units to the right. 1, 2, 3, 4, 5, 6. And you're going into negative 6 units. 1, 2, 3, 4, 5, 6 units. We'll do the same thing for the minor axis. We're going up 3 units. 1, 2, 3 units. And we're going down 3 units. 1, 2, 3 units. Lauren? No. A is under the y-axis, so the distance, not screwed up. Well, let's go back and look at it. The center is at the origin 0, 0. The major axis we said was the y-axis, so we need to go up 6 units, down 6 units, okay? That's my fault. I apologize. So 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4, 5, 6. Then we need to go over 3 units. 1, 2, 3, 1, 2, 3. So what we did, Lauren, is we started at the center, and since the major axis was the y-axis, we used A and went up 6 units. And we used A and went down 6 units. And the minor axis was the x-axis, so we used B and we went over 3 units and over 3 units. No, the larger denominator determines the major axis. And I always use A for the larger number. Yes. Okay. All right. So we have our ellipse. We need to add the focus and also get the vertices. Now, obviously, we can look up here and write the vertices down. We went up 6 units, so we have a vertices at 0 and 6, and a vertices at 0 and -6. We went over 3 units, so we have 3 and 0, and -3 and 0. So then we want to find the focus. The equation to the foci is a squared minus b squared is equal to c squared. So what's a squared? 36. What's b squared? So c squared is equal to 27. So c is equal to the square root of 27. And don't simplify that, y'all. I know that it's 3 square roots of 3. But let's just leave it as the square root of 27 so you can estimate what it is. Plus or minus the square root of 27 is approximately a little over 5. So you're going up 1, 2, 3, 4, 5, and a teeny bit more on the first focus. You're going down 1, 2, 3, 4, 5, and a little bit more for the second focus. As the focus gets closer and closer to an endpoint, it gets skinnier and skinnier. As the focus gets closer and closer to the center, it becomes more like a circle. A circle is an ellipse where A and B are equal. So let's look at another one. The next problem asks you to write the equation in standard form. It is a little bit trickier. We know it is a conic section. We'll talk more about how to determine what type of conic section later. But once again, it's just like circles. We want to get all the x's together, all the y's together, and move the constant to the other side of the equation. So the first thing we're going to do is rearrange this and get x squared minus 4x plus 9y squared plus 54y. Move the constant to the other side of the equation, so minus 49. I'm going to go ahead and complete the square on the first one. Half of 4 is 2. 2 squared is plus 4. But don't forget to add 4 over here. We're working on the opposite sides of the equation. So we're going to add on this side and add on the other. So we have x minus 2 squared plus, we need to factor out a 9 and get 9 times y squared plus 6y is equal to negative 45. We want to take half of 6, which is 3, and square it and add 9 here, but we're not adding 9, we're adding 9 times 9. Because we have 9 here, we're adding 9 times 9. So we get x minus 2 squared plus 9 times y plus 3 squared is equal to 36. The next thing we want to do is divide by what? Hopefully you will divide by 36 because the equation needs to be equal to 1. So you get x minus 2 squared over 36 plus 5 plus 3 squared over 4 is equal to 1. To be in standard form, the equation needs to be equal to 1. Once we do that, we then want to find all the parts that we need to find. On the test, I would list those for you. So if you're not trying to remember what they are. First, we're going to find the center. The center is 2, -3. And we want to find the major axis and the minor axis. So what is the major axis? The x-axis. The minor axis is the y-axis. A squared is equal to 36. So A is equal to plus or minus 6. B squared is equal to 4. So B is equal to plus or minus 2. The length of the major axis is 2A. So it's equal to how much? 12. The length of the minor axis is 2B. So it is equal to 4. The first thing we want to do is graph the center. So the center is at 2 and -3. The major axis is the x-axis. We're going over 6 units. 1, 2, 3, 4, 5, 6 units. We're going in the other direction. 6 units. 2, 4, 6 units. The minor axis is the y-axis. We're going up 2 units, down 2 units. So when we graph our picture, we have something that looks like this. Let's talk about vertices or endpoints. If the major axis is the x-axis, if we add 6 to 2, we get 8 and -3. And we have subtract 6, we get -4 and -3. On the minor axis, here to here, we actually could look at the point, or we can take the number 2, +2, and -2, and add it to the y coordinates of the center. So the vertices there would be 2, and if we add 2, we get -1, and if we subtract 2, we get -5, which is what this point and this point are. The next thing we need to find is the focus or foci in R2. A squared minus B squared is equal to C squared. So we know that A squared was 36. We know that B squared was equal to 4. So we have C squared is equal to 32. Or C is equal to the square root of 32. We know that that is between 5 and 6. So we'll go over 1, 2, 3, 4, 5 and a little bit more. And 1, 2, 3, 4, 5 and a little bit more. So we have focus 1 and focus 2. When you're working on opposite sides of the equation, you'll add on one side, add on the other. Only on parabolas are you working on the same side of the equation. subtract from the inside, add on the inside, subtract on the outside. And the next problem, it gives you a picture against your right equation. In order to write an equation of an ellipse, you need to have the center, and you need to have A and B. So the first thing we'll notice about this problem is we know that it is horizontal because we have a picture and we can look at it. So we are in the form of x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So on this particular picture, they tell you that this point is -4 and 0 because the focus, which we call focus 1, is -3 and 0. We'll call this focus 2 is 3 and 0, and we have another endpoint here. First thing we need to do is find the center. I'll remind you that the center is the midpoint from endpoint to endpoint, or foci to foci. So if we were asked to find the center, we would say -4 plus 4 divided by 2. 0 plus 0 divided by 2. So we have the center at 0, 0. So over here, we would say x minus 0 squared plus y minus 0 squared is 1. And then we have to determine what a squared and b squared are. How far is it from here to here? 4 units. So a is equal to 4. So we have a is equal to 4. So a squared is equal to 16, or we could leave it as 4 squared. But we don't know this distance. We have to find it. We do know this distance. What is that distance? 3. It is also c. So to find d, we're going to have to use the formula for the focus. The formula for the focus says a squared minus b squared is equal to c squared. We have a is equal to 4. We don't know b, and we have c is equal to 3. So we get 16 minus b squared is equal to 9. So we have minus b squared is equal to -7. So b squared is equal to 7. We don't really need b. We needed b squared. So I would go up here and just plug in 7. Not 7 squared. If you want to do that, you're going to have to put the square root of 7. So d is equal to the square root of 7. So for that particular ellipse, the equation would be x minus 0 squared over 16 plus y minus 0 squared over 7. On this particular problem, 17 through 21, some of the problems are like this. They ask you to write an equation for an ellipse that satisfies the given information. Has a focus of plus or minus 1 and 0, and has a length of the major axis is 4. might be helpful to plot the focus on the chart so that you sort of know whether you have major axis on the x or parallel to the x-axis or parallel to the y-axis or either on the y-axis. So I would plot positive 1 and 0, negative 1 and 0. So that tells me that the major axis is the x-axis. In the center, it should have what? So we have x minus 0 squared plus y minus 0 squared. Everybody see that much. Now the question is, it says the length of the major axis is 4. So I know that that's 2a is equal to 4. So a is equal to 2. So I have 2 squared here. What is c equal to? C is equal to 1. Alright, so c squared is equal to a squared minus b squared. So we have 1 is equal to 4 minus b squared. The minus 3 is equal to minus b squared. So b squared is equal to 3. Once again, we need b squared. So we have that. The square root of 3 is, you can put it in your calculator if you want. It's above 1, below 2. So above 1, below 2. So we just make it about here. And we know that the length is 4 units. So that So we're going back over the homework exercise on page 438, 13 through 21 odd, 27 through 37 odd. I also would put the answers to the night before's homework on parabolas online. So if you want to check your answers, they're online. I've written out each one of them, so hopefully if you're having trouble, you can